In this specific video, I wanted to show you some examples of solving systems by using the substitution method. So first of all, for the substitution method, you need to check if any of the four variables is isolated by itself. That is not the case here. 6x minus 4y, nothing is by itself. 3x plus y, nothing is by itself. So because we don't have anything isolated, we will have to do that step by ourselves. So check for any coefficients that you have of 1. This is a 6 and negative 4. Now, no ones. This is a 3 and there's a 1. So the easiest way is to start by isolating the second y just because it has a 1 in front of it. So that's what I'm going to do. I'm going to take the 3x over, and it would be y equals negative 3x minus 1. I like working with boxes because they help me stay organized. So since I isolated the second y, I will put that expression for the other y. That's important. Take that and put it to the other. So let me continue my work right here. I'm going to the first equation, and when I get to y, I stop, I open a parentheses, and I'm putting the expression of the other y, and that would be my first substitution. So I took this y quantity and I put it in the other y. This is my first substitution. If you're doing your first substitution correctly, in front of you, you should have an equation with only one letter, one variable. It's either all x's or all y's, depending on your problem. If you happen to have x's and y's after your first substitution, that tells you and me that you're doing something wrong. Stick to this equation, solve it so you can get x. If I distribute correctly, a negative times a negative here would be positive 12x. And negative times a negative here would be positive 4. And there's my distributive property. Now I'm going to put together like terms. That's 18x plus 4 equals 40. I'm going to take the 4 over, and I have 18x equals 36. And finally, I want x by itself, so I would divide both sides by 18. And that gets me to x equals 2. I got one of the two variables. I need to go back to get the other. This is where the second substitution happens. I'm going to put the second box in the first box. So that's my second substitution. So here's what I have. Y equals negative 3. Instead of putting x, I'm going to put its equal. So here's my second parentheses for the second substitution. Second substitution tells you and me that you're almost done. Minus 1. And negative times a negative, negative times a positive is negative. And you're adding two negatives, so you're going to get more negatives. So there's my answer. My answer as an order pair is 2, negative 7. So if you have an answer, please write it down as an order pair. Let me just make this a little bit better. There we go. Please go back and check your answer in the original system. You can do it in your head or you can substitute. So if I take this, which was my original, if I put x2 and y is negative 7 on the first one, I'm going to be getting 12, and negative times a negative is positive. 12 plus 28 is 40, correct. And on the second, I have 3 times 2, which is 6, minus 7 equals negative 1, which is correct. So both of them are giving me a true statement, which means that is the correct answer to the system. Reminding you, as we did with graphing, you have to have, if you have an answer, you have to have it in parentheses. An answer would be an order pair. Now, similar with graphing, okay, we're still solving systems, we're just using another method. So at any point when you're solving a system, no matter what the method is, expect one of 3 possible outcomes. Most of the times you will have one solution. Other times you can have no solution or many solutions. So let me take you to another example here. Let me switch my screen and start writing our second example for right now. Our second example right now would be 2x plus y equals negative 3 and negative 6x minus 3y equals negative 2. Again, I need to start by using substitution, which means I need to isolate one of the 4. The best to isolate would be the first y because that's the only one that has a 1 in front of it. So take the 2x over, and therefore I will put this in a box. So because I solved for the first y, I need to put that expression to the other y. So here's the work for the first substitution. Negative 3 parentheses. I'm putting that y quantity from the first in the second. I'm right here. Don't forget, finish your equation equals -2. So there's my first substitution for this problem, and it's looking good because I only have x's in front of me. You need to do the work here. And now after you do the work here and you try to put x's together, you see something weird. 9 equals -2, which is never correct. So you're getting a false statement. So false statement tells you no solution, which means you would have pale lines if you really graph them. Okay, now I'm just wondering, before I go to another system, if there's any way I can verify that from the beginning. And the answer is yes, because if you compare these two equations, you can see that they're multiples of each other by -3 on the x and the y, but when we get here, it's not. For example, let's say you multiply the first equation by -3, you're going to get -6x minus 3y equals 9. So you're going to have -6x minus 3y, and this will not be the equal part. So you're going to have a false statement eventually. So there's your answer. Let's go and do one more here. My third one that I wanted to share with you is -3x plus 12y equals 9. And then I have x minus 4y equals -3. All right. So here, the best way to get started is the second x, because that is the one that has a 1 in front of it. Now, you're not always guaranteed that you're going to have a 1. If you don't have a 1, go to the one that is having the smallest coefficient. You don't always have to solve for y as we did before. It depends every time of your system and your numbers. Here we go. So I'm isolating this, and I'm putting this x for the first x. So here's how it looks like. Now remember, when you're doing your first substitution, you shouldn't be having any two letters, only one. So if you start distributing here correctly, you will get something weird again, but it's not as weird as before, because now you can clearly see it, that y's are opposite, so you're going to get a true statement now, not a false statement. So this is the opposite from before. This is a true statement, which is telling me that I'm having many solutions. So if you remember from the graphing method, this means really that you're having the same line twice, and we call it coinciding lines. Coinciding lines. Now again, is there maybe something, a hint from the beginning that tells me that I'm going to be having many solutions? And the answer is, again, yes. Because if you compare these two equations, they're really multiples of each other the whole way through. If you multiply the second by -3, -3x plus 12y equals 9. You're going to be getting the same equals the same. So it's the same line twice. Some people cannot see that right away, and that's fine. But you need to start being more observant now.